Okay, today we'll talk about construction in the seismic areas. Construction in seismic areas, it is maybe directly one of the important part of construction because seismic resistance it is important task for buildings and structures located in the regions where the earthquake is one of the important loads which should be taken into account during the design and the calculation of the building. So, what we know about just seismic activities, about earthquakes, we know that they can really destroy any type of the building. Actually, according to the maybe speed, according to the big or not so huge forces and so on. So there are many actually features according to what and can be destroyed building. But in the same time, there are we have this special measures which can help us protect building from the collapsing, um, protect building from the errors during earthquake, during the seismic activities. So if we'll talk about estimated points of earthquakes, so in our regions accepted the 12 point scale, and according to it we know that the most maybe strong, most dangerous regions located in the south part of our country. And for instance, if we talk about Almaty and the Almaty region, there are 9 and 10% estimated strengths in that regions. So it requires from us, like from engineers, from architects, to apply the special measures and special designs which will protect our building from the collapsing. Uh, there are two ways or two variants of protecting a building from the collapsing, destruction of collapsing. It is the passive and the active methods. Um, Nowadays, most of all applied the passive method of building protection. So passive method include itself the simple ways of protecting. So according to the right shape of the building, right and sufficiently enough thicknesses, height, um, enough type of material to protect building itself without any active variants of protection. But in the same time can be applied the active method of protection, but it requires some additional expenses because to add
Good morning.
yes, of course, money to add into the construction some additional elements, bracing elements, joists, bearings, which will decrease the effect of seismic load to the building and will help to building to sense the less magnitude, to sense less points of earthquake in comparison with the traditional passive protecting buildings. it of course will take from us more expenses for it. And sometimes some customers are not ready to spend that additional resources, and they are construct buildings in the passive technology. Uh, Results of the earthquakes is the visual distractions, visual cracks inside not only the earth or in the surface of the earth, but also in the buildings. So our building is designed to be durable through the all operational time of it using, and should withstand all loads, all designed loads, and all combination of the loads. So one of the important combination, it is combination between seismic load and, for example, other statical loads. Так, ребят, меня немножко опять выкинуло. Сейчас я возвращу демонстрацию. Так, все нормально, презентацию видно?
Да.
Да.
So, like we know, the earthquake, it is a processes which begins the deep inside the earth, and so the sheer processes of earth start from the hypocenter, so the central point of earth, where mm, from which starts the shaking, which starts the movement of the earth with the big speed, and it can be directly located under the building, or maybe from some distance of the building, and so on. So according to the location of this uh, hypocenter or epicenter, so the strong and um, strength of the mm, earthquake is act to the building. So it cannot be calculated the epicenter of the earthquake, because not each of the scientists and people who are included into this maybe stage, maybe included into the science about the earthquakes, cannot say where will be the next directly where will be the next earthquake, so, and how, in what time it will be, and what where the epicenter will be located, and so on. So all these questions are not open for them too. They just can create some documentations according to the last earthquakes and create their own program. So like periods of the earthquakes. So through some periods there can be. So, but it doesn't mean that there will be or will not be earthquake and so on. But if will be it 100 years ago or maybe 200 years ago there was a strong earthquake like it was in our city in Almaty, so we need to take this into the account that um, there was and 100 years ago and maybe it will repeat again. And so this is required from us to accept all knowledge, accept all achievements during we are design our buildings to make our buildings more durable and more resistible to the construction. So the pictures illustrate the epicenters and the hypercenters from the earthquake. So how deep inside it can be located and in what direction it moves during the design during it begins, so when it begins. So the nature of the fluctuation of the soil depending on the distance from the epicenter. So the main document which we use during the design building and structures in the seismic regions, it is construction in seismic areas. So this documentation was approved in 2017. It's considered like the active document, and it's required from us to um, answer all requirements to during the design of buildings and constructions in the seismical regions of our country, so inside our country. And so if we will look through that documentations, we'll found the information that most of our cities, it is more than 90 percent of all buildings are located in the seismic regions. Actually, there are in some cities some less points of seismical activities. In some countries, more points of activities, but more than 90% of cities are included into that table. So there is a special table which show us in what city what number of points of activities according to the earthquakes. So and all that information and all applied designs for constructions present the special requirements. So for ensuring the earthquake resistance. So it all should be applied not only from the that document, so construction seismic areas, but also it depends according to the location of the building itself. So according to the soils, according to the underground water levels, according to the type of the building, according to the frame of the building, and so on. So many positions should be taken into account during the design buildings in the seismic areas with the seismic resistant purposes. So ability of the building or structure to withstand seismic influences, call it earthquake resistance. So to achieve the necessary seismic resistance of buildings under the construction seismic areas, it's necessary to take into the account not only normal loads acting to the structure, but also horizontal pulsating ones that occur during the earthquake. So when we discussed about types of the loads, we divide all loads into the two groups according to its principal action scheme. They are vertical loads and they are horizontal loads, and also there are varying loads. So we're not now discussing about varying loads. We just will discuss about vertical and the horizontal. So most of the statical loads, they are vertical loads. So it is dead loads of construction, it is time loads, time acting loads, and other loads, other statical loads. And the horizontal loads is the load which are directly act from the horizontal positions. So in the transversal position, like wind is can be called like horizontal load, and the seismic load is also considered like a horizontal load. So these loads are can be divided into two groups again, like natural load, and sometimes horizontal load can be not natural. So for example, in the industrial buildings, if there are bridge crane, so there are also horizontal loads from the wheels of the bridge crane located inside the building. So it also call it like not natural load, because it are produced from the processes inside the building, from the movement of the bridge crane during its lifting up the heavy loads. So combinations of the load. So important thing is to take into account not only separately the loads of building, but also the combinations of the building of the loads, like seismic loads and dead loads, seismic load and snow load, seismic load and other statical loads, and so on. But in the design and the calculation of the building, we not take into account the wind load if the building locate into the seismic areas. So because it should be take separately and make the calculation separately of the seismic loads. They should not be stand near to each other and take both of them into the account. Actually, we can accept the wind load, and but we need to put it in other way. So not with the wind. So not the combination with the wind. That's an important thing. Um, what else? Ensuring the seismic resistance of buildings and structures achieved by the implementation of urban planning, space planning, and structural niches. So, resistance of the building can be accepted not only with the design, architectural design, but also with the urban planning. So, urban planning is a plan of the site where will be located the building. So space planning, it is right design of building itself, and the structural niches, it is the right constructional solutions which will protect building from the collapsing. So when designing the planning of populated areas in the seismic regions, it's recommended to zone the territory with partitions by non-built up space, green space, squares, channels. This requirement mainly fireproof, limits the spread of potential fires, so in additional rules provide a possible increase to 20% width of streets and gaps between the buildings. So the free space which will gap with the additional place for streets, for squares, green spaces. It is in one way creates good urban planning in the territory of construction, but in the same time it is resists the building, so resist each building from the collapses and the meeting each with each other. So I mean that if there will be a big strong earthquake and the building begin to move, begin to shake, for example, the other buildings which should not be stay near to the existing building. So the dimension between the buildings should be sufficiently enough to protect each of the building from the collapses, because if they will be located near to each other, they can destroy each self by during the movement, and they will transmit so much and huge load to the soils, which in combination with the earthquake can produce the or increase the number of points, number of degrees of earthquake. That is a negligible moment for building itself. So, during development the project, it's required to guide the following main provisions: space planning, structural solutions, satisfy conditions of symmetry. So, on the next slides, we'll see what does it mean symmetry and the uniform distribution mass and the stiffnesses, and so how it is important to use symmetrical construction, um, like the way of protection from the seismical distractions. So the plan itself should have non-asymmetrical shape, and also should be divided into the anti-seismic seams. So anti-seismic seams are divide the long building into various or into several parts of the building. For example, 30 meters distance building can be or should be divided into two parts. So dividing to little pieces is required to the answer the questions of requirement according to the documentation construction of seismic areas, and protect building from the torsional moments. so which are can be found if the building will be long and will not be divided by using this so additional seams. So these seams are also used when the dimensions of the building are in plan exceeding the standards. So anti-seismic seams are used in buildings with load-bearing walls, with the double walls, and the frame buildings with the double frame. And the width of seams should provide the horizontal displacement of the elements. So anti-seismic seams is divide building on all its constructions, will be it walls, foundations, partitions, not a matter. It divided also. Maybe in the external part of the building there will be no visual dividing of the elements, but inside the building uh, from each part of the seams will be directly installed the additional walls, additional columns, additional foundations, and they will have a little free space between each other, so they have no rigid connection. They just located near to each other like one building, but they work separately, and they will not meet which is other if there will be the earthquake. If we'll look at the picture and think about what type of the shapes are recommended to construct in the seismical areas, we'll see that most effective shape of the building is the traditional shapes. We know it. They are rectangular, square, circular, and sometimes combination of these types. What do we see? A. It is recommended symmetrical system for the construction in seismic areas. B. Not recommended asymmetric type of the system. So, what does mean asymmetric? Asymmetric means that the location of the bearing walls is concentrated only in one part of the construction. So it means that this part will have the more own weight, and during the building will stand on the soil, on the ground. It will transmit non-asymmetrical load, so varying load to the soil, and it can produce more settlement in the bottom part of the basement, and through the time it can lead to the problem of shrinkage of the building, in the settlement of the building, and so on. That's why it is important to use symmetrically located main bearing construction is the building with ordinary step, with one way or two way located bearing constructions, and so like in cross sectional and also in the longitudinal direction. So, and next it is with the brick in the internal walls. So breaking into the internal walls, it is location of the bearing wall in the longitudinal direction, and it in the central part where they are located the lattice or elevators. There can be free openings for the technological purpose. The foundations of the building must be laid at the same level. Under the load-bearing stone walls, three foundations should be used. When installing pile foundations, preference should be given to piles. Mm, Foundations actually for the construction of seismic areas, it is one of the first construction which are installed, and the important one, because problems with the foundation can lead to problem for all building. So not enough constructional solutions for foundations, not good materials, not right design, so not sufficiently enough reinforcement inside the foundations can create the problem of existing constructions um, during the operational time, can produce the negative effect to building, like shrinkage, like collapsing of some of the construction and so on. So that's why foundations should have really strong and durable conditions, um, should be right protected the connection between foundation and other constructions, so will be they are connected rigidly, semi-rigidly, or maybe just it will construction put it on the foundation, so free connection. So all this actually important thing to discussion, important thing to during the design, the constructions, and so on. So anti-seismic belts. So anti-seismic belts are used to increase the bearing capacity of external and the internal walls. Most of all, it located above the windows and installed lintels, and under the ceiling, under the roof, under the covering. So it connects all walls between each other and transmits the load acting from top part of the building um, to the masonry wall, to the other block walls, and so on. So it is important to use in the construction site the anti-seismic belts. Especially it is important for low-story buildings. So low-story buildings should be protected also enough, because sometimes we apply the method of protecting from the resistance, seismic resistance, not sufficiently enough, and this additional elements will create this special rigidity of building, and walls which are made from the little pieces.